everybody. Welcome to Tier 1 Interventions, where we work on helping you gain the core in your classroom. I am Cheri Dotter, your classroom coach. That's Cheri with a C and Dot with a stutter. I'm here today with Jonily Zupanzik, your instructional coach on mathematics, and we are here to help you learn how to deliver your math instruction in a very unique way. Today, we're going to talk about the pain problem. Jonily, get us started.
Hey everybody, I'm Jay-Z in the house, Jonily Zupanzik, and Tier 1 Interventions is, as Cheri said, strengthening your core regular classroom. So this is for specifically the classroom teacher partnering with the intervention specialist, instructional coach, curriculum leader, principal, special service provider, occupational therapist, speech therapist. How can kids get exactly what they need in the Tier 1 core regular general classroom? Too often we have kids leaving the room to be pulled out for small group Tier 2 or Tier 3 intervention.
This week, we're going to talk about part 3 of the background to the pain problem. I was doing a webinar for OTs earlier this month, and one of the OTs that was on that call said to me, I never even considered that parentheses, square root sign, the division sign would be something that my kids needed me to address with them. So I say this for your awareness as well, anybody who's out there listening to the podcast, that not only do we need to help kids with letters and numbers, we also need to help them understand the symbols that go with mathematics, the symbols that go with social studies, the symbols that go with music and science, because they don't make the connections.
When we talk about improving number sense, we always say this is an inborn, innate, intuitive understanding of number. That cannot be explicitly taught. It must be experienced. And that's what all of this module is all about. But Cheri makes a point. What does need to be explicitly taught are the connections between those conceptual, contextual experiences and the symbols and notation. That must be explicit. We must tell kids exactly what it means over and over again and make those connections to the conceptual. But kids aren't just going to figure out a parenthesis. They're not just going to figure out a square root. That must be explicitly and deliberately taught. I say it, they hear it, and then they tell me what I just said, and they learn it. So very important to understand this as we're moving through the science of math that is up and coming. The differences between what needs to be explicitly taught in mathematics and what cannot be explicitly taught in mathematics. With the science of reading, the collection of research on how students learn to read, reading must be explicitly taught. That's what the collection of science says for reading. My fear when we move into science of math is we're going to try to parallel that for everything. But what we're missing in schools is a high level of number sense, and that can never be explicitly taught. It must only be experienced through these things. That experience is what is going to provide the functional aspects for students to be able to individualize where they are and be able to work independently on mathematics. We seem to not be able to ever get to a point in any classroom at any grade level where students can independently work on mathematics because we're not focused on iterated and repeated reasoning. Using reference tasks and bringing them back again with a different number, kids already have been explicitly taught the process. Now they can independently repeat the process with other numbers. This is also how we individualize and build independence in mathematics. What are some of these other non-academic functional pieces? That's the question that we're going to answer here in part 2. Part 2, what are some of the non-academic functional pieces that need to be included in Tier 1 general core instruction so that kids don't have to be pulled out of the room to go to a separate small group, a separate teacher to learn how to function, behave, regulate, and manage their learning. And I say this has to do with rate because one of the examples of rate is speed. How fast? That's innate and intuitive right there. Because as Teresa mentioned, when we go to the gym and we get physical and we do movement, we could have short distance running races and use a stopwatch because what we're measuring is distance per time, and that is the pure definition of rate. I don't have to teach it as rate in second grade. We can just do these short distance runnings and we can document the distance to the finish line and then the time it took for each student to get there. And we're collecting data, we're experiencing it, we have physical movement, and then we're going to use those numbers for mathematics. Now, not only can I improve my number sense by seeing number as shape, like with a quick dot, to start to give meaning to number, now I can physically feel number because I can see who is faster. And whatever number that is going to be a smaller number as far as time. Because if I have the same distance, the finish line is at the start and finish line. I have the same distance for every race. But the smaller the number, why does that mean the faster they got there? Because the definition of rate, one of the definitions for rate, is distance per time. So I can take my younger kids and do these things and collect data, and now they can physically feel rate. This is what we're missing in mathematics. So that's an example of a functionality, a non-academic way to put movement into mathematics, but also be able to improve number sense experientially. So let's talk about some other functional non-academic features of interventions that can be done in the regular Tier 1 classroom.
Before you get started, Sarah has a question.
Sarah, question. And I'm not going to get started. I was going to turn it over to you, Cheri. Be ready with some other functional interventions. Sarah, go ahead.
Okay, I want to do two things, and I don't want to sidetrack too much. I did want to say yesterday at our Pi event, when you said rate, I was thinking one of the moments I loved yesterday the most, I was doing this, we called it our bike race activity. We basically had two hula hoops that were different bike wheel sizes. And so I tried to keep the station flexible. I changed the questions depending on the students that were there and what I felt like. But I had these two students, and one of the questions I would ask is estimate how many rolls of their wheel they thought it would take to get to our finish line, which was marked off. But this one brother and sister, we got to talking about the number of rotations for the wheels, and I think this would relate to paint problem, right? Because it's the inverse relationship, right? And I asked, or they came up with a statement the bigger wheel has less rotations because of the length of it, and the smaller wheel would have more rotations because of its length. And so it's just really exciting to have that rate conversation without using any math terms. We were just talking about what we see, what we know, that kind of thing. So that's more an observation comment. My question though was,
hold off on that question because I want to
sure.
make a point on that too. And that's just like fraction. My younger kids, my younger students, and even my older students, when we do experiential contextual with paper folding with fraction, they will come to discover that, wait a minute, the bigger the whole number, when that number is the denominator of a fraction, the more pieces, but the smaller the piece. And that's really difficult for kids to overcome unless they experience it contextually and conceptually. And I'm going to put this up here, another reference task is paper folding that we need kids to experience, which is really connected to what Sarah's talking about with the rotation of the wheel, because it's that sort of counterintuitive inverse understanding. When I ask kids, which is bigger, 1/8 or 1/4? 1/8 is always the answer. It's wrong, but it's very popular. Okay, so kids need to understand that the larger the number of the denominator, the smaller the pieces. And they only can do that. I can tell them 586 times. And we do this in schools. We tell them and tell them and tell them, guys, we've told you this. Yeah, you know what? That's the problem. Insanity, doing the same thing over and expecting a different result. That's why we need to unlearn, relearn, rethink these contextual, conceptual, experiential ways of delivering math instruction so that kids can figure it out on their own. Then we can explicitly teach the association and the connection to the symbol and language. Sarah, question though.
Now you make me think of our math night. I did a recipe scaling with kids and your fraction thing, right? So we were talking about, I told them, I said, when I bake, I like to use as few tools, a few measuring tools as possible, so I don't have to clean as many things. So when we were looking at the recipe, like if it said whatever the measures were, and I said, what if we only used the 1/4 teaspoon? Like, how is that going to change, what we do? And one of the students did get to that point. We're using a smaller teaspoon, so we need more of them which is what you're saying about that fraction, right? The smaller the denominator, the more we're going to need to get to that.
So think about it. When we skip count by 8s and we skip count by 12s, which one is going to get to 120 faster? See, that's rate. But Sarah, let's talk about this for a minute. You teach in a cyber school. So were you guys all together on site yesterday? What's happening?
Yeah, sorry. So yesterday we host in-person events for special, once a month or special occasions, like our Pi Day is one of those regional activities, and we were in person.
Love it so much. Okay. What's your question?
Sorry, my question is back to the symbols, okay? Because this comes up consistently with the 6th grade teachers. The multiplication transition to dot and parentheses from the little X. And my question is, how early on is it okay to start introducing the different symbols to elementary students?
Kinder.
Okay, so
Kinder.
from the get-go, just interchange them
Embed
and
it in.
know it means the same thing. Okay, all right.
So what I'll sometimes do, this is a good question. What I'll sometimes do is, remember when we had the 3x5 on the dimension and blah, blah, blah. Sometimes I'll just do 3x5. But I tell kids, this is not a dot number. That's our 3x5. Because if I put the dot here, and I do this in kinder 1, 2, if I put the dot here, I have to be very specific where the dot goes, because this means 3x5 rectangle, but this is a dot number. It's a decimal number, $3.50. So I'm introducing and exposing that way early, starting in kindergarten. By 2nd grade, kids should be able to see that my by number, my rectangle notation, and this is what's important about calling that blank multiplication chart the dimension chart. I can use the word by, I can use a dot, I can use parentheses, and it really has nothing to do with multiplication. It's a notation of dimensions. Follow-up question on that. Okay, other functional non-academic aspects. Cheri, talk to us a little bit about what that looks like in your setting and how it can be done in the regular classroom.
Sure. What I mentioned this a little earlier. I lost my page. Where did it go? I always have to have pictures for everybody, right? All right. So I was talking a little bit earlier about interoception. Interoception is the response of our nervous system where it's going to turn on and turn off parts of the body based on what our needs are. Our brain, our body, and our blood system and our nervous system, it wants to keep our heart and our brain functioning. So there are times in our system where we don't send as much blood to our digestive system or different parts of our body. There's an actual nervous system. It's called the autonomic nervous system that turns on and turns off. It'll increase or decrease blood heart rate depending on how much activity we are needing. I think I am sharing. Oh no, I'm not sharing any screen yet. The another part of it is feelings, and that's what I want to share the screen for. And that is that we have 8 senses, 8 emotions: joy, trust, fear, surprise, sadness, disgust, anger, and anticipation. We have about 4,000 feelings. But the difference is that emotion is that first 7 seconds before we even think about it. It's that gut response that our body does without us even thinking about it. It is part of the subconscious. It is part of our innate nature. We talk about numeracy cycle being innate. We've got 8 core emotions that are innate. So kids that are refusing mathematics or handwriting or whatever task you're asking them to do, one of those 8, most likely fear, is overcoming their ability to engage in the task. So the emotion, I said there's 8, is a neurobiological response to that initial gut reaction before we can even think about it. Once we can think about it, once it brings up into our conscious, then we can evaluate it, and that's when it becomes a feeling. But there's also something else that I haven't really ever talked about before, and that is called mood. And that is our disposition. That is the kind of that thing that lasts forever. That's why people can be in a depressed mood or a sad mood. That's different than emotion. When it becomes this long, drawn out disposition and it's the way we're feeling over time, that is our mood. And we can change those moods, and that is going to change that emotional response. That in itself is the best way to re-engage kids in their education, is changing their mood. It's the most difficult part of education, but that is the key. The key to making that change is motivation. So we need to change how they're motivated to engage in the mathematics. And what Jonily is teaching about engaging kids in mathematics is a way of circumventing those moods and remotivating kids into their education.
And what Cheri and I together teach on, and what she's talking about, is umbrellaed underneath this phrase, focus triggers. A focus trigger is the exact action that I, as the facilitator and instruction, can take with a student to re-engage and to motivate. I'm going to go back to my kindergarten audio. Yesterday in this kindergarten class, and this was all non-academic, and this might be very criticized by educators and administrators, but I'm telling you, if you want kids to be motivated intrinsically, if you want kids to be able to function at a very high level, If regardless of disability or ability, if you want kids to be able to engage in the task at hand and work independently, you'll hear many focus triggers on this kindergarten audio. I'm going to tell you about a few of them right now. So whenever I teach a class of kids, no matter the age level, in the first 3 minutes, I can find out who our special students are. Okay, it's not rocket science. Ended up finding out yesterday, and you'll hear how I do this on the audio, because what I will do is I will give some prompts to gather student perspective to get a feel for the classroom. And I might say, so yesterday I introduced myself. I say, I'm Mrs. Zoo Panzik. Zoo, like where animals are. Pan, like frying pan. Sick, like you're not feeling well. Say that. Zoo Pan Sick. Boom, there's a focus trigger right there. I give an association for my name, then I make them say it. That's actually 2 focus triggers. Creating an association, my last name, Zupancic, it's a little difficult. Make an association. Zoo, where animals are. Pan, frying pan. Sick, like you're not feeling well. Okay, so that's one focus trigger, is to make that association. And another focus trigger is make them say it. Make them repeat it. Rote. Okay, so you guys say it. Zoo, pan, sick. Okay, so focus triggers. There's 2 right there, just very subtle. And you'll hear that in the audio. And now that I've pointed it out to you, it'll be very intentional. You'll see that. And so as I'm having them do this, I watch for the kids that are laying on their desks or being like, the panther. Okay. Hey, come on. I'm not exaggerating at all. Okay. So then I go on and I start telling them that I used to have a classroom like this, and I just like to go in different math classrooms and do math with them. And then I went on. Another focus trigger is to share the purpose. Okay, another focus trigger is to share the purpose. I went on to say, how do you guys exercise your body? Oh, we work out. You lift weights. You can run. Da, da. That's all exercise for the body. But what do we do to exercise the mind? And they were like, we work out, we lift weights, we run. I'm like, no. I said, no, we exercise the body. And then another little lady, she raised her hand. I called on her because she plays school really well. And she's math. I'm like, that is exactly right. We do math to exercise the mind, the brain. So that is a perspective in and of itself. So when I'm teaching kids, I tell them, I don't teach math, I teach thinking. So when they ask, gosh, when are we ever going to use this? Probably never. You're never going to have to think. Okay. The thing is, thinking is my content. Like I teach thinking through the vehicle of mathematics. See, that's an unlearn, relearn, rethink right there. So if you are an educator, an intervention specialist, or instructional facilitator of mathematics, you teach thinking. You just use mathematics to teach that thinking. Couple other, and then I found out my good friend Jace. I thought it was Chase, and then I was like, and they were like, no, Jace. I'm like, oh, because my first name is Jonily. And then they were like, oh, but we have James and Jesse and it was just a whole thing, and it was fun. But the kid beside Jace kept speaking for him. So I picked up on that, and I said, oh, are you his secretary? He's yes. And I'm like, okay, I need to keep this kid near Jace. You pick up on these things, but what I'm doing is I'm using focus triggers. I'm getting kids to hone in and focus on one thing so that they can give me their perspective so that I can teach to their perspective. Okay? Making a lot of associations and connections. So once I find out who Jace is, we come to carpet. I make sure Jace is near me and his secretary on carpet. So that was beautiful. Okay. We go back to our seats, but I make Jace stay with me because I knew this kid needed to wonk the willies out. Okay. I knew explaining what we were going to do with the 120 chart and starting that facilitation with the kids before I mini lessoned to that small group. I knew Jace needed to just be up and moving and not at his table. He wasn't going to get anything out of that anyway. So he was beside me, and then he started spinning. And I'm like, Jace, you keep spinning. He would spin, and then he'd jump, and then he'd spin, and then he'd jump. And then he was behind me and the whole class was attending to me and ignoring Jace because they know Jace is special. So I moved strategically to another area of the room. Jace stayed over there doing his jumps and spins and whatever. And then I finished explaining and I said, okay, so now go ahead with your 120 chart. I'm going to come to your groups. I'm going to help you. And I said, Jace, come on back. And I said, Jace, no, sorry. This was before they were making squares with blocks. Blah. Jonily, you got the whole story messed up. Anyway, doesn't matter. The point is, while I was explaining that we're going to make squares and what that means and equal sides, and I totally screwed this up. We should re-record this, but we're not going to because I don't have time. Anyway, so then he comes back. Before I went and observed other groups, when he came back, I said, hey, do you know what we're going to do right now? And we're going to make squares. I didn't expect him to say that because he was off over in La La Land. But do you see, he needed to do all that. And it didn't bother any of the other kids. They didn't ask why he was doing that. They probably intuitively know why he's doing that. He came back and I wasn't expecting him to say, we're making squares, but he did. And I'm like, do you know what a square is? And he was getting a little weird. And I was like, you know what? Here's your blocks. Go ahead, make squares. And then he, for the next 10 minutes, was so focused and engaged and in tune and working independently. See, a focus trigger for him, he's got to spin and jump. Then he can attune to the task.
And he was listening to every word you said.
Why?
Tune in next week where I answer the question, why?